Okay, in the first two sections here, we're going to look at just some general organic knowledge, a little bit about the overview for all the different parts we're going to look at. And we're going to go with here. So the first thing I'm going to look at, what is organic chemistry? Okay, it is the study of carbon compounds and anything that contains a carbon, a nitrogen, an oxygen, or a hydrogen is often an organic compound, but it always has to have a carbon and hydrogen. So it can have some of the others, but it always has carbon and hydrogen. Okay, the structures of organic molecules, there are two reasons that structure is very important. And the first one is that the shape determines the physical and chemical properties, and these shapes also determine how they interact with other molecules, which is kind of the chemical properties part. Okay, two things here that you have all filled in that you don't have to fill anything in for is the stabilities of organic compounds, and because it varies. And a group of atoms will determine how an organic molecule functions. That's called the functional group. We're going to look at those at the end of the chapter here. Functional groups are the center of reactivity for organic molecules. They're going to be things like alcohols, ethers, ketones. We're going to have O's, H's, N's, things like that. Double bonds that will make them a little more reactive, and we call those functional groups. Okay, there are some acid-base properties for organic substances. Many of them are either acidic or basic. Carboxylic acids have the functional group of CO, double bonded O with an OH. You have amines that are very important organic bases, okay, with something with an N and some sort of hydrogen. Okay, R there just means carbon groups, okay. Some molecules can be both acidic and basic. One end can be a little bit of acidic, one end can be a little bit of basic, and they're kind of interesting the bigger the organic molecules that you often see. Okay, so now we're going to look at just an overall hydrocarbons. Okay, hydrocarbons are molecules that consist only of hydrogen and carbon, and there are different types of these hydrocarbons that we're going to look at. And the first ones are what we call alkanes. Alkanes contain only single bonds. Okay, we call these saturated hydrocarbons. And the reason there is that they have the largest number of possible hydrogens. So we call those saturated because they have as many H's connected to them as you could possibly have. And a good example of an alkane is this guy right here to the right. We have a C and 4 H's. It doesn't really matter what angle you draw these H's at. They're not really Lewis structures like we did before when we talk about the angles really meaning something here. It doesn't really matter how they look. Okay, alkenes, on the other hand, are hydrocarbons that contain at least one double bond, and that will be this guy right here to the right. Okay, we have at least one double bond between our carbons. Hydrogen will never have a double bond. Hydrogen only ever forms one bond. You have what we call alkynes with a Y. These are ones that contain at least one triple bond. And the guy we see right here to the right has that triple bond. Okay, so we've got alkanes, alkenes, and alkynes. We also then have what we call an aromatic hydrogen. And aromatic hydrogens, or aromatic hydrocarbons, excuse me, are carbon atoms in a ring structure. And that's what you have over here to the right. And that is actually a benzene ring. And you will often actually see these guys looking something like this, 6-sided ring, but you'll see double bonds in them, so they'll go every other. So you'll have one here, nothing, one there, there. This and that actually are the same thing. It's not showing you the double bonds that are in there, but there actually are because carbon always has 4 bonds. So you can draw kind of different ways to draw the same structure, and we're going to look at that as we move throughout the chapter here. Alkenes, alkynes, and aromatic hydrocarbons are all examples of what we call unsaturated hydrocarbons, meaning that they don't have as many of those H's as they could possibly have because they have something else. Different classes of hydrocarbons exhibit very different chemical behaviors. Their physical properties tend to be about the same, but they have very, very different chemical properties. Some are very much more reactive than others.